a couple exponent rules. If I had 4x squared times 6x to the third, what is the simplified version of that? So 24, which is just 4 times 6, x to the fifth. Why is it x to the fifth? I'm just counting the total number of x's. I have x times x, and I'm going to multiply that by x times x times x, which gives me a total of 5. But what if I had 4x squared to the third? 4 to the third is 64. X to the sixth. Why is it 6 this time, not 5? Why do we multiply these exponents? Well, what does a third power mean? 3 versions of whatever's being multiplied, and the thing being multiplied is x squared. So I have 3 versions of x squared, and then if I just use my original rule of counting up the x's, I have 6 of them in that case. Okay? What about 4x squared times 2x to the negative 5? 8x to the negative 3. Okay, that's a little weird. What does x to the negative third mean? So you guys have learned the rule. This is the same as 8 over x to the third. Can you tell me why? Okay, so that's the rule. You bring down all the negatives. Do you know why that's the rule? Oh, that's one way to look at it. Let's consider what is 4x squared over x to the fifth. 4, we could either do 4x to the negative 3 or 4 over x to the third. And this is the preferred version. But why is it 4 over x to the third? What's going on here? We are subtracting. Why are we subtracting? Oh, so if you wanted to, you're saying we could use our rules of negative exponents and bring this up and get x to the negative 5, and then we just use our adding rule. Okay, that's a good explanation. We understand the adding rule, but we still haven't figured out why we subtract. Well, consider this. Four x squared over 2x to the fifth. Why does that equal 2 over x to the third? I cancel them out, right? What is x over x? 1. X over x? 1. So that's why we subtract. If they're on the same side of the fraction, they work together and you add them. If they're on opposite sides of the fraction, they work against each other and they end up canceling out. Does that make sense? So if I had 6x squared y to the negative 3z over 18 x to the fourth y to the negative 2 z to the third. Let's do negative 3. How do I simplify this? So the numbers are easy. 1 over 3. And I might need the 1, I might not. We'll see. How about my x's? So they fight it out. The 2 on top cancel 2 of them on bottom, and I end up with x squared in the denominator. What about my y's? They need to switch. So So I'm going to bring this one down here to get y to the third. I'm going to take this one to the top and get y squared. So when they fight it out, I'll have 1 left in the bottom. What about my z's? The -3 becomes a +3. And now they're not fighting, but they're working together. So z to the 4th on top. Because I had 3 in the denominator and I had 1 in the numerator. So when I bring that up, those work together to be z to the 4th. Does that make sense? Because it's 6 over 18 is the same as 1/3. Yeah. Okay, what about this? Okay, so I'm going to bring this in and multiply it. What am I going to multiply it by? I'm going to multiply it by 3 to the 1st. So there's a little exponent of a 1 right there that we don't write. So make sure you don't put this as a 9, because it's not 3 times 3. It's 3 to the 3rd. So it's 27 x to the 6th. What's going to happen with my y's? So y to the -12. So I can just put y to the 12th in the denominator. Okay? Make it a little bit harder. Okay, I recommend you make your life as easy as possible. Simplify first. We could bring the 2 into everything, but that's going to be terrible. So let's simplify first and then bring in the 2. So 14 over 21 simplifies to be, what factor do they have in common? A 7. So we pull a 7 out of both of them. We end up with 2/3. Okay. How about my a's? Ooh, look again. Look again. A to the 7th. Because this is going to move up here and become a to the 4th, and if they're on the same side, they work together to be a to the 7th. B to the 3rd in the denominator. So we're going to flip both c's. So this one becomes a 2, and this one becomes a 3. Now they fight it out, and I have c on bottom. Now I'm going to square everything. 4 a to the 14 over, not 6, 9 b 6 c squared. It's a 7. It's a really bad 7. Okay, what about this? Okay, let's make our lives easy. We're going to pull out, or what can we take out of this fraction? 4 would work. 8 would work. Anything bigger than 8? Nope. So 3/4. Okay. So this one drops down. A to the 7th. B to the 8th. C to the 7th. Raised to the -2. Because your math teacher has no idea what's going on. Thanks. -3. Okay. Now let's make this easy on ourselves. Do we really want to bring in a -3? Because that's going to flip everything, right? So how can we deal with this and not have to rewrite it? Flip it now, or when we write our answers, just flip our answers. Okay? This is going to have the effect of flipping everything on top and everything on bottom. It's a negative exponent, and negative exponents flip fractions. But in this case, we're going to flip the top and the bottom at the same time. Now, if you want to write it all as a -3 and then flip them all at the same time later, that's fine. But I already know that my answer for this one is going to be in the denominator. So 3 to the third is 27. The negative is going to drop it down to the denominator. What's that? Lonely? Do you have too much experience in that area? Poor Cash feels for that 27. Okay. Anybody know what 4 to the third is? 16 times 4, 64. A to the 21. B to the 24. C to the 21. Did I make a mistake somewhere? Okay. You're no longer lonely. You have 27 versions of yourself. Doesn't sound like a very good party to me. Okay. These assignments are due tomorrow. You do have the answers to both of them on that answer sheet. So, get to work.